So hello everyone, welcome back to another particular class of our reagent chemistry series. So here in this particular class 29, we talk about the oxidation of alcohols, and here we talk about some unusual oxidative reagents. So in this particular class, we talk about uh, metal based oxidation, then we talk about some radical based oxidation reagents, and then hypervalent iodine based oxidation reagents. So we begin with our discussion with the metal based oxidation reagents. So the metal based oxidation reagent is a tetra N propyl ammonium perruthenate. There is a TPAP based oxidation and the structure is this, and here the ruthenium metal is present here. So ruthenium tetroxide is the RuO4, and to a lesser extent the perruthenate ion, that is the RuO4 minus, where the oxidation state of ruthenium is 7, are powerful than rather non-selective metal oxidants. This ruthenium tetroxide is a very powerful metal oxidants which actually oxidize to alcohol to acid. However, here we talk about the TPAP based oxidation. Now this TPAP based, due to the presence of this tetra N propyl ammonium part, which is written here, that perruthenate salt with large organic counter ions. So this is the large organic counter ions. There is the tetra N propyl ammonium. So this provides to the mild and selective oxidation in variety of organic solvent. So as I already discussed previously, that ruthenium tetroxide is a very vigorous oxidating agent. It will directly oxidize alcohol to acid. But presence of this first the perruthenate ion, where the ruthenium is +7 oxidation state, and presence of this particular bulky organic counter ion part, the selectivity of ruthenium tetroxide and the selectivity will increase and reactivity will decrease. So this actually stop oxidation of alcohol to their aldehyde for the primary one, and the secondary one it will be stop as the ketone. But if we add direct RuO4, then what happened, that it will directly for the primary alcohol it will directly convert it to acid. Okay, that's why this particular large organic counter ion is required. Also, it is written here that in conjunction with the stoichiometric oxidant such as the N-methyl morpholin N oxide, is the NMO that actually used in the OSO4s also. TPAP oxidation are catalytic in ruthenium and operate at room temperature. That I already discussed. If you remember, then osmium tetroxide OSO4 based reaction where the cis dihydroxylation occurs. So there also NMO is used, so that OSO4 used as a catalytic amount. Here also NMO is used, so that this particular will become used as a catalytic amount. And that's actually signifies that this is also a redox reaction takes place in the ruthenium part. So that we'll discuss in the next slide. Okay, and these reagents are relatively non-toxic and non-hazardous in nature. Now there is a reaction here you can find that this is the primary alcohol. Now in presence of TPAP, NMO and DCM is a solvent here. It will generate their corresponding aldehydes, and here also molecular shifts used. Now to achieve the high catalytic turnover, since as I already discussed that in the presence of NMO, TPAP is actually used in the catalytic amount. So there is a catalytic turnover is there. So that catalytic turnover means that how many catalytic cycle can be performed by the catalysis before it getting deactivated. So this particular improve the catalytic turnover, more the catalytic turnover, more the catalysis efficiency. So addition of powder molecular shifts to use to basically remove the water that is generated during the reaction. So this particular catalytic turnover getting increased, and that's why molecular shift has been used here. Okay. So the following oxidation state change has been proposed to occur during the reaction that I already discussed, that since the NMO is used, that means that ruthenium side there is the oxidation reduction takes place. So what happened that ruthenium 7 is the initial condition. It gets 2 electron to get ruthenium 5. Now this ruthenium 5 will undergo disproportional reaction to generate ruthenium 6 and ruthenium 4, and ruthenium 6 will get 2 electron to get ruthenium 5. So this is the catalytic cycle was done in this particular reaction conditions. Now let's talk about N-oxonium mediated oxidation. Now N-oxonium salts are mild and selective oxidant for the conversion of primary and secondary alcohol to corresponding carbonyl compound. Okay, and these oxidants are actually unstable and generated in situ in a catalytic cycle using a stable stoichiometric oxidant. So this is the N-oxonium salt. Okay, now it's react with the alcohol, either it is primary or secondary. So here it is a secondary alcohol. So react with get this particular byproduct and our corresponding ketone. Okay, and this particular N-oxonium salts can be prepared by oxidation of a nitrile radical or hydroxylamine. So here also we can say that since this is formed by a radical pathway, then we can say that tempo will be a good successor of this particular N-oxonium formation. So 2,2,6 tetramethyl 1-pyrronidyl, that is a tempo which catalyzes the oxidation of alcohols to aldehyde and ketone in presence of variety of stoichiometric oxidant such as MCPBA, sodium hypochlorite, that is NaOCl, bis acetoxyioidobenzene. These all are the oxidants. So what happened at tempo in presence of acidic condition, it will generate the N-oxonium oxonium. Okay, so then this will actually used to oxidation of primary secondary alcohol to their aldehyde and ketones in the presence of this type of stoichiometric oxidants. So here we will discuss some examples. So here in this particular structure we can find that this is the OH, the primary alcohol here. Now here tempo is used and the oxidant here is used the NaOCl. Okay, so it will actually convert to their corresponding aldehydes. Also it will do this type of oxidation also, alcohol and the sulfur getting intact, sulfur selenium getting intact here. There is a tempo, BIAB is used as a terminal oxidant, or we can say stoichiometric amount of BIAB is used to synthesize the alcohol to their corresponding aldehydes. Similar is there also. Now let us talk about another particular unusual oxidant, that is the hypervalent iodine mediated oxidant. IBX is the O-iodoxybenzoic acid, is a mild reaction for oxidation of alcohol, and this is the structure of IBX. Here you can find that iodine having the hypervalent state. Okay, and this actually acts as a mild reagent, so it will do a secondary alcohol to their corresponding ketone. Now remember that tertiary alcohols are not getting oxidized in this process. Primary and secondary alcohol will actually go their corresponding aldehyde and ketone compound, because one alpha hydrogen is necessary for oxidation. Okay, similarly here also is the pyridine, and there is a one OH is there. This is the primary one. So in the presence of IBX and DMS as a solvent here is used, so it will generate their corresponding aldehydes. Also sometimes that what happened that here it is there, so sometime what happened that excess amount of IBX will lead to form alpha beta unsaturated carbonyl compound from their corresponding saturated alcohol or carbonyl compound. For example, you can find here that this particular is the primary alcohol and here IBX has been used in the excess amount. So instead it will converted this particular alcohol to their corresponding aldehyde, but also it will generate a alpha beta unsaturation here. Similarly, here in this particular example, you can find that this is only a carbonyl compound is there. 2 equivalent of IBX is used to generate alpha beta unsaturation here. Similar case here also, here both the secondary alcohol is there in a conjugate fashion. So in 6 equivalent of IBX, it is a huge amount of IBX has been used to generate their corresponding alpha beta unsaturated carbonyl compounds. So this particular part is very, very important and you have to remember that part. So next we talk about another particular oxidative agent, that is the sodium hypochlorite. Now here we come the selectivity part. Like if you have both primary and secondary alcohol in your compound and you want that specifically the secondary alcohol getting oxidized, then sodium hypochlorite has been used for that particular job. Sodium hypochlorite in acetic acid solution, it selectively oxidizes secondary alcohol to ketone in the presence of primary alcohols. Okay. So here you can find this is the primary alcohol and this is the secondary alcohol. So sodium hypochlorite is actually do selectively secondary alcohol oxidation over primary alcohol oxidation. So here the chemoselectivity is observed. For example, here you can also find that this is the secondary one, this is the primary one. In the presence of sodium hypochlorite, the secondary one getting oxidized and the primary one keep here, and in the second part is the protection of primary alcohol is there. So this particular primary alcohol getting protected. So if you don't know about the protection deprotection, you can definitely check my protection deprotection lecture series also. Here also second part, here only no, here also primary and secondary both the OH is there. So this is the primary alcohol, this is the secondary alcohol. So selectively secondary alcohol getting oxidized. Here also same, that the secondary one getting oxidized and primary one is no harm. Okay. Another selective secondary alcohol to ketone oxidation is there by using N-bromosuccinamide in aqueous condition. So NBS in aqueous condition selectively oxidize secondary alcohol in the presence of primary alcohols. So this is also a chemoselective reagent. Here also it is a primary alcohol and a secondary alcohol. NBS will do the secondary alcohol oxidation. Okay. However, some cases not only NBS can be used, direct bromines also used for the activated alcohol selective oxidation. So this will be, you have to remember, if there is a bromine was there, then you also go via same pathway. So with this we have to end this particular lecture, and with this we have to end the oxidation of alcohols to aldehyde or ketone. Now in the next class onwards, we talk about the oxidation of aldehyde to carboxylic acids. So thank you for listening.